Hello, how are you guys doing? Just quickly let me know if I'm audible, if the volume is fine, if the voice is loud and clear. Just quickly let me know. Alright guys, welcome to Unacademy JEE English, a brand new channel by Unacademy, India's largest online learning platform for IIT JEE. And on this channel, everything is taught to you completely in English so that no student feels left behind. Alright, so today is the lecture 3 of this series, and the topic is work, power and energy. So this series, as in case you don't know, is aimed for 2020 aspirants. So what we're doing in this series is we are going over some key concepts very quickly, and then we are trying out some problems and focusing on problem solving. You know how to tackle the problem solving topic by topic, so that you can quickly recap all your class 11 topics and 12 topics. So first we started with class 11 topics because I know most of you guys who are about to take their JEE are still, you still have your class 12 topics fresh, but most of you guys do not feel very comfortable with class 11 topics. So that's why we are talking about the class 12 topics first. All right, class 11 topics first. So now before we get started, let me introduce myself one more time. All right, my name is Rohit Dixit. I studied mechanical engineering at IIT Delhi. I have 7+ years of teaching experience wherein I have taught at the top names in the JEE coaching institute industry. All right, I myself was JEE rank 447, so I've been in your shoes. I know how a student can feel when preparing for such a competitive exam as IIT JEE, and I've cracked it, so I can share my personal experiences and tips, and I know the subject inside out, so I can help you guys to understand the subject better. I've coached many students to top ranks in IIT JEE, and I hope I can keep doing that here with you guys. So moving forward, let me also tell you a bit about the Unacademy subscription and the benefits that it comes with. You have live classes, you get to interact with your educators, you have live polls and leaderboards, you have test series and analysis, and you have live doubt clearing sessions. And trust me, these will give your JEE prep a huge boost. Alright, especially your test series, analysis, and live doubt clearing classes. I mean, sitting at the comfort of your home, you're getting live doubt clearing classes online. I mean, that's just a wonderful thing. All right, and of course, you get access to India's best educators with your Unacademy subscription. All right. Now, how do you get this subscription? It's very simple. Follow these simple steps. Install the app. Once you've installed the app, go to the plus section, select your goal as IIT JEE, and click on Get Subscription. All right. So it's that easy to get your subscriptions. And if you look at the pricing has been kept very affordable and reasonable. So you can see for 24 month subscription, the pricing comes out to be 1500 per month, which is roughly 50 rupees a day, which is nothing compared to generally what fees you must be paying everywhere else. So Unacademy is trying to provide you quality education at very affordable prices. And on top of that, if you use my code to get your Unacademy subscriptions, and my code being RD Live, you get an additional 10% off. All right, so make the most of this affordable offer, and trust me, it's going to be worth it when your JEE prep is concerned. All right, so also do not forget to join us on the Telegram app using the link shown above. All right, once you join this app, you will get notifications of all our uh, lecture schedules and upcoming sessions. All right, hello Dr. Archie, hello Pavan, how are you guys doing? Good evening. Good evening to you as well. All right, so why don't we get started with today's discussion? The discussion is about work, power, and energy. If you remember last time, we discussed about the work energy theorem, and then last class we discussed about conservative and non-conservative forces, and we defined what a potential energy is. And we ended the class with the work energy theorem, including potential energy, and as a special consequence of that, we discussed the case of conservation of mechanical energy. Hello Delta Rage, how are you? Alright, so we'll move forward from there. We'll look at the conservation of mechanical energy and we'll try and see what are the applications based on and how to attack your problems. Alright, so we realized in the last class that in absence of any non-conservative forces, you can apply conservation of mechanical energy to solve your problems. Alright, and how do you go about it? In such cases, you identify two instants first. One, according to the given data, so some information must be given to you. So based on that, you choose a first instant, and then according to what has been asked to you, you will choose a second instant. Now, once you have chosen your initial and the final instants, then you write the expressions for kinetic and potential energies for these two instants. Alright, and once you have written those, you apply the conservation of mechanical energy and find the unknowns. So, but before applying mechanical energy conservation, always remember to check whether there are any non-conservative forces or not. This will only be applied in absence of any non-conservative forces. Alright. So, why don't we start with a practice problem? So, you've been told an object of mass m is suspended vertically from a spring of spring constant k. It is released from the natural length of the spring. You to find the maximum elongation of the spring. Alright, if you try to solve this problem with the help of Newton's laws, trust me, it gets very, very complicated. With the help of conservation of mechanical energy, the solution is very, very easy. And that's the power of this new tool that you have acquired. Alright, so let's try this problem. Let's see what the answer comes out to be. So guys, go ahead, give this problem a try. Solve it using conservation of mechanical energy. And let's see how you guys do. How much you remember from yesterday's discussion. Alright guys, give it a try. Quick. Just write in the chat to let me know that you're trying. Just write trying in the chat so that I know you guys are trying this problem. Alright. Is it even trying? Okay. No problem, Baba. No problem. Get hold of your pen and paper. I'll wait for you guys. So go ahead and give this a try. Great. Alright, I'm waiting for you. See, the idea in this series is to guide you through the process of problem solving, to guide you about how to think when you attack a problem, how to approach a problem. Alright, because I think for 2020 aspirants, the time that is left now, they should be focusing more on their problem solvings now, and a quick recap of key concepts is also very, very important. So that is why we are just focusing on that. Alright. So I'm not, in this series, I'm not taking topics from scratch. I'm not explaining the derivations, all the derivations. But however, I do discuss the main concepts, and I do discuss some key points related to all the concepts that people. Yes, yes, Pawan, the spring is ideal. There is a word ideal missing here. That is why the an is there. Alright, an ideal spring. Alright, I think you forgot to type that. That's why you see an written in front of the spring, because the ideal word is missing. Alright, so by the way, what are the properties of an ideal spring? So ideal springs, one, are massless, two, they can be compressed or elongated to any lengths. We do not put restrictions in those. I mean, in real life, you realize when you're trying to stretch a spring, I mean, till some time it will act normal, but if you go on stretching, what will happen? Its coils will start getting uncoiled, and eventually it will start losing its spring properties also. And you can ruin the spring if you stretch it too much. All right. So in ideal springs, we don't assume that to be happening. In ideal springs, we assume that, all right, you can stretch it to any length possible. All right. Similarly, if you realize for a real spring, obviously you can't compress it beyond a point, right? I mean, there has to be a restriction where all the coils start touching each other. So you can't compress it beyond that point. But in case of ideal springs, we do not consider that also. We assume that the length is big enough and you can compress an ideal spring to any length. All right. So remember that. Whenever your question says ideal spring, you immediately know it's a massless spring. Yeah, that seems about right. Yes. So again, as I said, this problem will be approached using the work energy theorem. So first, let's make a diagram and try and understand what the first situation is going to be. So initially, I've been told that my spring is at its natural length. All right, so let's assume that this is the situation initially. So initially, I know what is the compression here. It is 0. All right, and the speed of this block is 0. Why? Because you've been told that the mass is released from the natural length. So if it is released, we assume that the initial speed was 0. So this will be my first instant. All right. So why don't I just define a reference point for my potential energies? The reference point of my potential energy for ease, I define as this only. Yesterday I told you guys that you can take any point as your 0 reference point for potential energies. That does not matter. That never changes your answers. So usually it is chosen as the ground, but it does not matter. You can choose it according to your ease. All right. So in this situation, I'm choosing this level, this horizontal level that my mass is initially at as my 0 level for potential energy. Now, let's assume that this mass starts moving down. Let's analyze what must be happening to the mass. So as soon as the mass has one force acting on it right now, which is mg, right? And of course, the spring is not exerting any force. Why? Because there is no elongation or compression on the spring. But the moment it starts coming down, imagine an intermediate position. All right, so fine. Let's talk about an intermediate position. So let's assume it has slipped down to here. Now you realize it will have two forces acting on it. One mg, which will be pulling it downward. Another spring force. All right, which will be pulling it upwards. So which would mean that the net force as it moves down will start to reduce. All right, why? Because as it keeps on moving down, the spring force keeps on increasing. All right, and since the spring force is acting upwards and it is increasing constantly, so the net force acting downward starts to decrease. So if the net force downwards is decreasing, so does its acceleration. Its acceleration downwards starts to decrease. Eventually, there will come a point when the spring force will become equal to the mg force. That is what we call the equilibrium position. All right, there the net force would be 0. However, suppose when it reaches this point, and here the Fs is equal to mg. However, the problem is that it accelerated all this while. And because it accelerated all this while, it must have gained some speed. Let's call it v dash. All right. So it must have gained some speed. Now, because of this speed, it will continue to move downwards. And as it moves further downwards, the Fs goes on increasing further and further. So you realize the net force will start acting upward now. And this force is increasing all the time. So this force will start retarding this this block, and eventually you will have a situation where this block will come to rest. All right. So finally, after descending a certain distance, it will come to rest because of all the net upward force that is acting on it because of the spring. The 2 classes are going on the channel. Okay, Delta Rage. Which other one? Whatever you want to study right now. Whatever you want to study right now, by the way. Yes, Dinkar, when the spring force becomes 0, then what? So when the spring force becomes zero, I don't know what you're trying to say. The spring force will be zero only in this condition, when the elongation is zero. Alright. So this will be uh, my final situation when the mass has come to rest again. Now you realize it has come to rest. It has a force acting upwards still, right? Because it's still elongated, and we have already crossed the point where mg and fs were equal. So we are below that point. So below that point, the Fs will obviously be greater than mg. So the net force acting on this would be upward. As a result, it will start to go up again. So you realize this will be the maximum extension that the spring faces. Alright, so here. So let us assume that the maximum elongation that the spring eventually gets is x. Alright, and this will be my situation 2. So this is my situation 1, this is my situation 2. Now that I've identified my initial and the final situation, let's start writing the kinetic and potential energies. Let us also check what were the forces acting on the block when it was moving down. There were two forces which acted on the block. One was gravitational force and another was spring force. Now there is no third force acting because we assume the air resistance and everything else to be negligible. Alright. And since both these forces, the force of gravity and the force of spring, are both conservative, so I know that there are no non-conservative forces acting on my body, and hence I can apply the conservation of mechanical energy in this case. Alright. So I have concluded that there are no non-conservative forces, hence I can apply the conservation of mechanical energy. Now I've also identified my initial and the final instance. Let's start writing the expressions for kinetic and potential energies. So in my first situation, what will be K initial? The K initial would be 0. Why? Initially I realized my U was 0. Alright. What was my potential energy? So potential energy initial, there will be 2 kinds of potential energies this time. Remember, because there are 2 conservative forces acting, so you have to take potential energies corresponding to both of them. Remember, I told you yesterday that a potential energy is associated with a conservative force, and if n number of conservative forces are acting on a body, then there can be n types of potential energies in the system. Alright, and you have to take all the potential energies into account. So the initial potential energy could be 1, the gravitational potential energy, which will be 0. Why? Because it is at the 0 reference point of my gravitational potential energy. Now you also know that the initial elongation is 0, and you know for springs we also take that as the reference point, as the 0 reference point of potential energy. So I get the answer 0 for 0. This is gravitational PE and this is spring PE. Alright, both are 0 initially. Now let's talk about situation number 2. In situation number 2, again if I realize my block has come to a stop, it has come to a halt instantaneously, at least for that instant. Yes, it will start moving back up, but at this instant, when it just reached its maximum elongation, the block becomes stationary. Hello Nirja, how are you? So you need to remember that because V is 0, again, what will be the final situation kinetic energy? K final would also be 0. Alright. How about the final state potential energies? So P finals I can write as, let's talk about my gravitational potential energy. I realize that my block has come down by a distance x from my 0 reference level. So what will I write my gravitational potential energy as? Minus of mgx. So that will be my gravitational potential energy. This is my GPE, gravitational potential energy. How about the spring energy? The spring has gotten elongated by x. So spring energy, remember this, spring energy is always positive, alright. It is, minimum is 0, it can never be negative, alright, because we take the 0 extension as our reference point. So that is why we always consider spring potential energy to be positive. Doesn't matter whether it is elongated or compressed. Alright, Arnav. Hello, good to meet you. Hi Sandeep, how are you doing? So when I'm writing my potential energies, so one, I wrote my gravitational potential energy, which is this. Then I need to write my spring potential energy, which will be half kx square. Now I can say, let's apply energy conservation. So applying energy conservation, what will I get? Applying energy conservation, I can say that initial total mechanical energy, which is 0, should be equal to the final total mechanical energy, which is minus mgx plus half kx square. So from here, if I solve, I get my x equals 2 mg over k. That's it. All right. So 2 mg over k is my answer. Hi Akash. I'm good. How about you? Pawan, you had written a root. So the root is of course not there. The 1x get cancelled, right? So x is 2 mg by k. Now if you remember your SHM equations, you will also remember that in SHM also this block will eventually start performing SHM. So the mean position would come when the net force is 0. At mean position, the elongation has to be mg over k. Right now there are 2 attempts. Arnav, oh, you just entered class 10. Okay, that's great. Yes, right now there are the JEE Advanced is restricted to 2 attempts. All right, mains I think 3 attempts. All right, so that is how it goes. So have you been preparing for IIT NEER, Arnav? So I hope everybody understands this solution. And Pawan, please check. And I hope you realize you got a root sign extra. There is no root sign coming in the yes, that is fine. All right, so this will be your answer. Again, you realize the longer part of this is probably analyzing the situation in your mind. But with more practice, that analysis becomes easier and easier. And calculation-wise, there is hardly any calculation as far as work energy theorem or energy conservation is concerned. That is why the approach of work, energy, and power is such a powerful tool. It leaves you with scalar expressions, right? And it's always easier to deal with scalar expressions. Okay. All right, that is interesting. Yes, a lot of people have started doing that these days. They start pretty young. All right, so are you studying class 11th and 12th syllabus right now, or are you studying only class 9th and 10th syllabus? All right, till the time I ask my question to Arnav, why don't you guys try this problem? Now, in this problem, you've been told that a block of mass small m is dropped from a height h on a spring of spring constant k as shown. All right, you to find the maximum compression in the spring. So you can see it here. Here is a block. It has a mass m. It was released from a height h over this. So it drops down to here. The moment it drops here, it will be moving downwards. So it will press the spring and eventually it will come to rest. All right. So you have to find the maximum compression of the spring. So try this, guys. All right, I hope the question is clear to everybody. You have an object of mass m. It is being dropped from a height h on a spring of spring constant k as shown in the figure. You find the maximum compression in the spring. All right, that is interesting. That is very, very interesting. Now, if you finished your HC Verma part 1, did you solve all the questions? Wow, that is impressive. So I'm assuming that you're familiar with the vectors and calculus and everything. Wow, that's the level of competition. That's the level where the competition is reached these days. See, that's what I keep telling you guys. That see, smart guys like Arnav are already starting their prep so early, as early as class 9. Wow. 90% of the questions you were able to solve. That is great. That is great. That is very impressive. All right. All right. So guys, 2020 aspirants, get on your toes. You realize people like Arnav are coming for top ranks. Alright, so in case you did not start as early as Arnav, you still need to push yourselves hard. If you want to have any chance against a guy like this, I mean, I'm sure he's gonna crack IIT JEE very well if he's preparing that good right now. That's great to know, Arnav. So yes, you can watch my that's all right. That's all right. Obviously, your class, you were in class 9. That is bound to happen. That is not a problem. So, Arnav, you can keep watching. Yes, I know. Where I was teaching in my institute, also there were students from class 6 onwards only. Yeah, I know. So, I do know how stiff the competition is getting, day by day. It's just getting tougher and tougher. Yeah, I know. I know. I remember I used to teach this batch in back in my institute. So we had a separate batch for 5 students. Okay, so yes, they solved all their axiomas and stuff in class 9, 10th only. And in 11, 12, they were solving Erudov and tougher books, Krotov and everything. And we used to give them a lot of tough questions. All right, and all of them did very well. And even after that, the top rank I think was 48. One guy got a 48 rank in IIT Advanced. All right, he got I think around 20 some rank in around JEE Mains and finally 48 rank in Advanced. So even guys who are preparing for 4 years that rigorously are just managing to get in top 50, which is surprising. All right, great. So probably when you reach class 11th, you can join my courses and I can help you solve Erudov. For now, it's best that you focus only on HC Verma. All right, Arnab. Because yes, you're still way too young. I mean, and Erudov problems tend to get way more complex and a lot more mathematical. Okay. See, it's not a universal thing that it'll work for everybody, right? You have to be ready for it. I mean, I don't think a teacher should push students towards it. They should see if the students are ready for it or not. If the student is ready, then yes, well and good. If the student is not ready, then if you push, then that is what will happen, Pawan. What you're saying? Yes, that happens sometimes, Pawan. Yes. But trust me, the batch that I was teaching, that 5 student batch that I was telling you about, I mean, all of them did very, very well. Out of 5, I think all 5 got in top 500 ranks, and the top rank was 48. Then there was 112, then there was 128, and then there was 260 or something like that. So all of them got very good ranks. Wow, that is really, really, really impressive, Arnav. But you should not be saying all that here. Trust me, you're making these guys tensed, I'm sure. So it's good that you're watching my videos. All right, so it will be better for you, Arnav, if you watch my class 11th videos and class 12th videos. All right, because there I'm talking about topics from the scratch. All right. So okay. By the way, subservient Alisa had answered this question. I think the answer was mg over k, which is not correct. Sorry, Alicia. The answer is not mg over k. No. You have to find the maximum compression. All right. So Arnav, what you can do is I go live on Thursdays, Fridays, and Wednesdays, wherein I'm teaching topics of class 11 from scratch, from the very basics. So I think you should attend those so that trust me, you'll get to still learn a lot of things about the fundamentals of your topics. Because I know you're studying right now pretty hard, I'm sure, and solving the problems, but there are a lot of subtleties about concepts that people don't realize, and that is what helps you in solving tougher problems. If you're solving easier problems, you may be able to do that even without understanding your concepts very, very deeply. But when you want to solve advanced level problems and you want to solve them in one go, trust me, you need a deeper level of understanding. So watch those videos, develop a deeper level of understanding. All right. Okay, that's good to know. Great. So I remember the only thing that I did right when preparing for IIT JEE was that I was sorry that I was always very clear about one thing, that problem solving comes second. The first and the foremost thing is understanding your concept, understanding your subject. So actually, you know what? I was planning to take a session on that also, how to make the most of your lectures. Okay, M over 2HK. Mm-hmm. No, that may also not be correct. So why don't I solve this? All right. So let's see what is happening. So let's try and analyze the situation first. All right. So obviously this is my initial situation. I know about my initial situation. So I'm considering this as my zero situation. All right. And again, for my ease, I'm taking the reference level for gravitational potential energy as this one only. All right. So I'm going to assume that this is my zero level for gravitational potential energy. Now let's analyze the situation. Let's go through what must be happening or how the block moved. So I know from here to here, the block was under a free fall. So it would have accelerated with G. Yes, trust me, you feel that right now. Wait till you have some tough problems on rotation. Yes, Surendra, I think that might be the correct answer. I think that might be the correct answer. Pavan, I'm not sure. Let's just see how it goes. I don't remember this answer actually. So what must have happened? Till the time it reached here, it would have accelerated because it was free falling under gravity. So once it reaches here, it must have acquired some velocity v. Alright, so let's say, because that velocity v, it will go on moving down. But the moment it moves down from here, it will start compressing your spring. The moment the spring starts getting compressed, what happens when it reaches somewhere here, let's say? So it will have two forces acting on it. One will be spring force, which will be upward, and another would be mg, which would be downward. Alright. So you realize mg is a constant force. Mg value is never changing, but more and more the spring is getting compressed. The spring force is increasing. Alright. So as a result, what will happen is the net downward force acting on your block will start to reduce. Eventually, there will come a point where the spring force and the mg will become equal. Now, even there, the net force will be zero, but you realize up till this moment, from here to here, there was a net force downward, alright, because of which it was constantly accelerating. From here to here, with the constant acceleration of g, from here to here, the acceleration was going on decreasing, but there was still an acceleration. So because of which, it would still, the velocity here, let's say v dash, would actually be greater than v. Even though a force started acting upward, however, the net force was still downward, so it will still accelerate further. Its speed will go on increasing to some v dash until you reach a point where the spring force and mg have become equal. Alright, now because it already has this downward speed, it will go on further, compress the spring further and further. Now the net upward force will start acting upwards. Now that force will retard it, and eventually, because this retardation, it will finally come to a stop. So this is the final equation, a final situation where it has compressed the spring by, let's say, some distance x. Alright. So let's assume that this distance that the spring has gotten compressed from here to here is some x. And this is where it will come to stop. Now, when it has come to stop, we realize that the net force will be upward, so it will start moving up. So this will be the maximum compression. At maximum compression, I will realize that my final velocity would be zero. V final would be zero. Please remember this. Think about what must be happening. Analyze it in your head. Maybe try to visualize it with the help of a diagram. Alright, and think what kind of motion must be happening, what kind of forces are acting, and how the motion of block is getting governed by those forces. So once we have analyzed the situation, so here to here, from here to here, free fall under gravity. From here to here, there was still a net downward force, so it kept on accelerating. Then this is the point where Fs became equal to mg. So the net force was zero, but there was still some velocity, let's call it v dash, which will push it further down. So as it moves further down, now the net force will become upward, because as I compress the spring more, Fs would have increased and mg remains the same. The moment Fs becomes greater than mg, the net force is upward and the block starts to retard until finally when its velocity becomes zero. So this is my final situation. So this was my initial moment and I'll treat this as my final moment, which is 2. Now that I have analyzed this, let's take a look at what forces were acting during the motion of this object in the entire duration. So there was mg force acting from here to here. Alright, so from here to here the force acting was mg. Then what happens? When it moves from here to here, the forces acting were mg and the spring force. Alright, so in some part of the motion the force acting was mg, in some part it was spring force plus mg, but there is no third force. Alright, and what do we know about both these forces? That both these forces are conservative. The force of gravity and the force of spring are both conservative. So I know there are no non-conservative forces. Hence I conclude I can apply the energy conservation. Alright, now all there is left is to start writing the initial and the final kinetic energies and the potential energies. So let's talk about situation 1. So for 1, what is my K initial? K initial would be 0. Why? The block was released from rest. Alright. Similarly, what about my potential energies, initial potential energies? So initially, the gravitational potential energy would be 0. The reason being, I have chosen this as my 0 reference point. I mean, I'm just doing it for ease. You could have taken it as the ground. That would just unnecessarily get you one extra variable which is not needed. So always remember, just select your reference level for 0 potential energy as the initial position only, always. I mean, that's just simpler. Alright. Similarly, what will be the spring potential energy initially? So when the mass was here, the spring would be at its natural length. So the spring potential energy would also be 0. Alright. So remember this. So that is my initial condition. How about my final condition? Let's see. In my final condition, I realized my block was again at a final velocity of 0. It would have instantaneously come to rest before moving upwards, before moving back upwards. Alright. So my K final would be 0. How about my final potential energy? Let's talk about that. Now this is important. Please pay attention. Yes, ऊपर से आ रहा है. So, oh, the reference level for potential energy can be taken to be 0 anywhere. See, that is one thing you will not realize in class 9th. Yes, I know you have studied potential energy. But one thing that you did not realize is that we take ground as the 0 level of potential energy, but that is not a compulsion. You can take any level as your 0 potential energy level. All your answers would still be the same. It's just a matter of choice. Hello trillions, how are you doing? So just remember this, guys, that it is not a compulsion that you always take ground to be your 0 potential energy level, and everything up the ground has to have a potential energy which is positive. Trillions, you can watch this, but again, have you watched the last videos? And again, as I said, I am not discussing things from the very scratch. We're just having a quick recap of key concepts and moving forward. Now, final potential energy, you will realize this mass 1 came down by a distance h here and then another x here. So from here to here, it has come down a distance of h plus x. Alright, so from my 0 reference level, from my reference level for 0 potential energy, it has come down by a distance x plus h. So what will be my gravitational potential energy? Gravitational potential energy would be minus mg h plus x. Now I hope you realize why I am putting the minus sign, because it has come this distance, h plus x distance, below my reference, 0 reference. Alright. How about the spring potential energy? Spring potential energy, I know, is always positive. Alright. And my spring has gotten compressed by x. Alright. So that is the maximum compression, by the way. So because the spring has gotten compressed, so spring potential energy would be half kx square. Alright. Thank you, Arnav. Yes. Alright, thank you. So now what we do is we just apply energy conservation. Alright, so let's apply econ. Applying energy conservation, let's see what that gets it. We will actually get a quadratic equation. You realize I will get that minus mgh plus x plus half kx square equals 0. So that is giving me a quadratic equation. Alright, one root would be imaginary out of this, trust me. So that is why you're getting two roots. Alright, so let's see. You'll have to solve this quadratic now. So let's see what the quadratic becomes. Quadratic becomes kx square minus 2mgx minus mgh equals 0, or minus 2mgh. Alright, so that is what my quadratic looks like. Yes, of course you can. Always plus kx square, Alicia. The spring potential energy is always positive. Alright, it is never negative. Remember this. It is always positive. Does not matter whether the spring is getting compressed or elongated, whether the whether the movement is downward or upward. The spring potential energy is always positive. Alright. Remember this. Alright. So this is my quadratic equation. I need to solve this to get my answer. Let's see what my answer comes to be. I'll get x as 2mg now plus minus root of 4m square g square plus I'll get 8mg kh. Alright, over 2k. Now you realize I have to take the plus sign only. Why? I can't take a negative sign. Negative sign would mean x would become negative. Alright. But I know my x has to be positive only. Negative would mean I have elongated this spring. Alright. So I ignore the negative sign. These were the roots. But compression I know. For compression, this x is positive. For compression I know x is greater than 0. So I'll ignore the negative root and my answer becomes 2x equals mg plus, I can also take out 4 common from here. So that will be root of m square g square plus mg kh over k. That is my answer. Alright, I hope everybody gets this. Understood? Yes, Pavan. See, this seems like a very simple problem, right? This is supposed to be a regular, easy looking problem, but it is not that easy and obvious. When you solve it, you realize it is slightly tricky. Not a problem. So that is why I'm solving problems for you, right? So that even if there is a problem which no one gets correct, you know at least next time you will get it correct. Alright. So I hope everybody followed the solution, and if you have a problem then tell me. Sir, is your class for class 11 today? No, not today. Today I have, see Arnav, on Mondays, Tuesdays and Wednesdays I have classes for class 12th, and on Thursdays, Fridays and Saturdays I have classes for class 11th. Alright. Yes, Pawan, that is the point. JEE people really love these kind of problems, which are concept-wise. This is nothing difficult. See, these are all the concepts that you've already studied. The situation did not involve any very complex concept or a very complex mathematics. Subsequent, we can choose any point. We usually choose, according to our convenience. Trillions, I'm not very sure about that because I never went through the NEET syllabus very thoroughly. Alright, so I did not pay much attention to the NEET syllabus. like ever. So I'm not be able to comment. But I think it's very very similar. I think it's very very similar. All right. Maybe the mathematical derivations or the mathematical parts of it would not be included in NEET. What is Arnav? Don't worry. You're only in class 9. All right. So you still have a lot of time. Don't worry. You can join my courses once you come to class 11. Till now, you can keep on watching all the videos that I keep posting. Yes, do that. Do that. Yes, do that. Watch all the videos that I've already launched, especially on vectors and basic maths. That will help you with some of your troubles with the calculus, maybe. Okay. All right. So, did everybody follow the solution? Please let me know in the chat if you guys followed this solution. Again, a seemingly a simple problem, but with you have to be careful while analyzing this problem. All right. No difficult concept, not too much of maths also involved. All you have to do was solve one quadratic equation, which is expected from you guys. All right. You should be able to solve quadratic equations. Bye bye, Anna. All right. So let me know if everybody followed this and we can move forward. All clear? Give me an all clear, guys. Come on. Here's the solution one more time. There is nothing great. Good. All right. So let's move on and talk about one more problem. All right. So you've been told 3 objects of equal mass are thrown from a cliff of height small h with an initial velocity u as shown in the figure. Which one of them will reach the ground with the highest and the smallest speed? Alright, so there's your 1, 2 and 3. All of them are released from this point. You have to tell me which one will reach with the highest speed and which one will reach with the lowest speed out of 1, 2 and 3. What has been told to you? All are of the same mass and all of them are thrown from the same height with the same initial speed but in different directions. Alright, so one is thrown like this, one gets projected like this with u, 2 gets projected like this with u, and 3 gets projected like this with u. Which one will reach with the highest speed on the ground and which one will reach with the smallest speed on the ground? Alright, let me know quick. This is a conceptual one. You don't need to use too much maths here. Just think about the situation. You'll be able to solve this without writing the equations also. So let me know about the answer fast, guys. Think a little bit, analyze what must be happening in the situation, and then give me a quick answer. Come on. No. Unfortunately, that is not correct, Pawan. Nope. That is incorrect. Just think about the situation a bit. Think a bit. There is no 4th, Dinkar. There was 1, 2 and 3 only. Those are U's that I have mentioned. Yes, all are equal. That is the right answer. Alright. So remember, see, what are the kinetic energies here for all 3? K initial, they are the same, right? Because all of them were released with a speed u, and all of them have the same mass. So initial K initial was same for all. How about the P initial? P initial is also the same for all three. Alright, so how about here? Here also P final is also the same for all three. Right? If the kinetic and the potential energies were same initially, then finally also the sum of kinetic energies and the potential energies has to be the same. And since when everybody reaches the ground, they have the same final potential energy, which means KE final should also be the same. Just think about it. Use energy conservation. Alright. Since the initial kinetic energy and initial potential energy of all three objects was equal, and finally when they land on the ground, you know the potential energies of all these three will be equal again. So they have to land with the same kinetic energy also. So that is why you get your answer as your speeds are same for all three. Alright. If time was asked, if you were asked which one will reach first, then what can I say about then? Which one will reach first? Particle 3 will reach first. Why? Because it has an initial velocity component downwards. Alright, it has an initial velocity which is directed downwards. And the acceleration of all these are downwards only. No, the time will not be the same. Time will not be the same. 3 will reach first. Yes, Pavan got that right. Then the second one to reach the ground will be number 2. And one will reach the ground the last. Alright. Okay, so why don't we talk about one more conceptual question? Alright, let's talk about one more conceptual question which you don't need to use any equation or solve any equation to answer. Alright. So let's just say, okay. So let's just say you have a situation. Alright. So you have a point A. Hi, Mahesh Babu fan club. How are you doing? And then you have a point B here. So you have two paths to reach from A to B. Alright. This is vertical. Okay. So there is a wire going directly like this, and then there is a wire, another wire, which is in the form of a semicircle. Alright, so you have a semicircle with the radius this. Alright, so if this is distance 2d, let's say that this is distance d by 2. So this is a semicircle of radius d by 2. So that the complete distance is d. Alright. So the situation shows that A and B are 2 points. Now this entire frame is in the vertical plane. So remember. So this frame is in the vertical plane. So you have two wires connecting A and B. One wire goes horizontally and another wire goes like this as shown in the figure. It's a semicircle of radius d by 2. Alright, now there are two beads. One bead here is released from A with an initial speed of v. Alright. Now another is released from here with an initial speed v dash such that its horizontal component is v. Alright. So tangentially it is launched. Alright. And let's say probably not a semicircle then. Let's not take a semicircle. Yeah, need for a semicircle is not there. Let's talk about random curve. That'll make more sense actually. So I don't necessarily need to keep this as a semicircle. So this and another random curve. Alright, so random curve like this. So the situation that has been told to you is okay, so this is your point A, this is your point B, connected by two wires, one horizontal wire Another, a curved wire like this. So one bead here is launched from point A along the wire, horizontal wire with an initial speed v. And the second bead is launched from point A again along this wire with a velocity v dash such that, v dash can be broken into two components, right? One this and one this. Such that the horizontal component of v dash is equal to v. Alright, remember this. Horizontal component of v dash is equal to v. Got this question? Or should I repeat this? So two points A and B are connected with the help of two wires as shown. One wire is AB, which is horizontal, and another is a curved wire like this as shown. Hello Prabhat, I'm good. How are you? Alright, so points A and B. Let me just write the question quick. Points A and B are connected by two wires as shown. Alright, this is a challenge problem by the way. Right, so one is a horizontal wire, another is a curved wire. Now two beads are launched from point A, one along the horizontal one and second along the curved wire. Right, they are launched as such that if A has a horizontal speed of v to start with, alright, A has a horizontal speed of v to start with, and this guy, so bead 1 is released along the horizontal with a horizontal speed v. The second one is released along the curved wire such that the horizontal component of its velocity is also v. Alright, now the question is, assuming that both the wires are there is no friction anywhere, which bead will reach B first? The question is, which bead reaches B first? Yes, yes, trillions, you do. You do trillions, don't worry, you get a lot of money. Not for that kind of rank probably, not too much. Yeah, if you're anywhere in top 3, then you can, or even top 10, then you can consider you will make a lot of money. So the question here is, which bead reaches B first? This is a challenge problem with a proper answer and reasoning. I hope everybody got the question. Alright, why don't I give you options just to, make it easy. Option A, bead A. Option B, bead B. Option C, depends on the shape and length of the curved wire. So there are your 3 options also. Alright, I hope everybody got this question. Points A and B are connected by 2 wires as shown. One is a horizontal wire and another is a curved part. Okay, this frame is in the vertical plane. Remember, frame is in the vertical plane. Alright. So which means, what I'm trying to say here is that the gravity is there. Alright, do not ignore gravity. Now, what do you guys think the answer would be? Think about this. What do you think the answer is? Who reaches the point B first? Okay, so delta range is saying option A, which means bead 1. Sorry. The names of the beads were different. A and B were the points. I need to write 1, 2. Bead were given numbers. A and B are points. So delta rage thinks it's bead number 1, the one which was launched horizontally. Yes, I got that delta rage. No worries. Alright, how about others? Think about this. Alright, think about this. Let's wait for others to answer. Let me repeat the question till then. The points A and B are connected by 2 wires as shown. So one is a horizontal wire and another is a curved wire. Alright, now 2 beads named 1 and 2 are launched from point A. Bead 1 is launched along the horizontal segment of the wire such with a speed V. Now bead number 2 is launched along the curved wire with a tangential speed of V dash such that the horizontal component of V dash is also V. Alright, so if all the surfaces are completely frictionless, which bead reaches B first and why? And there is an option D, both reach simultaneously. Same time. So you have 4 options, which bead reaches the point B first, bead number 1, bead number 2. Option C says that the answer will depend on the shape and the length of the curved portion, and option D says at the same time. Both reach at the same time. So think about it, give me your answers. Okay, so Jay Brothers says it's option B, which means bead number 2 reaches B first. Alright, let's see what others think. Alright, so you have 4 options. One saying bead 1 reaches first, second saying bead 2 reaches first, third saying that they reach at the same time, and the fourth option being it depends on the shape and length of the curved portion. Okay, so Pawan is saying option C. This is interesting. I've got 3 answers so far and all 3 different answers. So can I have some more attempts to this problem? See, that is why I told you this is a wonderful conceptual question. Alright, just have to think about it. And let me tell you that I think, if not exactly this, a very similar problem was asked in JEE Advanced. So this is what JEE Advanced problems will be like. They will ask you, see, okay, finally 1/4 option. Alright. So 4 answers saying all 4 options. Okay. See, that is what JEE Advanced problems are like. Alright. They will leave you confused. See, I've got 4 answers and 4 people giving 4 different options. Alright, one saying A, one saying B, one saying C, and finally I got a D answer as well. That's the interesting part about JEE problems. They are conceptual. You don't have to use maths in this problem. Just think a bit, think about your concepts. And again, it can be very confusing. A very conceptual problem, not involving any calculation, but still so confusing that 4 answers I've got are entirely different. All A, B, C, and D seem possible. Alright. So that is why to crack JEE Advanced, you need to have a very clear and deep understanding. You need to know how to think about a problem. Yes, that might be, of course. K will not have to be the same, but yeah. yeah, Ke will have to be the same as initial. And that's all right. That's all right, Alicia. I think, at the first go, even I would think probably they reach at the same time. Why? Because the horizontal speed is the same, right? And the horizontal displacement is the same. In fact, if this frame was not kept in a vertical plane, if suppose this was horizontal on a table, where the force of gravity was not acting, then option D would have been correct. So let me tell you, D is the right answer if the force of gravity does not act. Alright, let's just discuss the answer. Let's just see what it must be happening. Alright, so let's just enlarge this part. So you realize if no friction is there, so this guy will continue moving with V all the time. Alright, so all the time it is moving V in the horizontal direction. And let's say this distance is D. So the horizontal displacement is D and the horizontal velocity for the entire duration remains V. No, no Pawan, you got that wrong. The correct answer actually is B. Alright, the correct answer is B. That is what. So, why don't I make another diagram somewhere else? So yeah, let's just discuss it over here. So let's talk about the case 1 first. So this is A, this is B. Alright, so my bead number 1, what that does is, that suppose it starts here with a speed V. Because there is no friction anywhere and this is horizontal, it will keep on moving with V here. It will move with V here. Alright, so you realize if this distance is D, if this distance was D, the time that it will take is D over V. Simple, as simple as that. Right, no confusion about that. Now, how about the second case? Now, that is where things get tricky. Alright, second case, you was told that the curve is something like this. Alright, so for discussing the second case, I am trying to forget this right now. Okay, so let's forget about the upward part and let's just focus on the curve part. So this is the path that the second bead has to take. Alright, bead number 2. Yes, Jay brothers, you were correct. But I was hoping to get an explanation also. So now you realize it gets launched with a speed V dash, which has a horizontal component of V. Right? What happens as it moves downwards? So let's assume what happens when it reaches here. It would have gained some kinetic energy. Why? Because it has lost potential energy, right? It has gained kinetic energy. Why? Because it would have lost some potential energy. So here it would move with some speed V double dash. And I know if the component of V dash was V and V double dash would be greater than V dash, so it has to be greater than V, right? And yes, energy conservation tells me that when it reaches back here, it will reach back with V and its horizontal component will again be V. But you realize, what about the horizontal components in the middle stages? What about that? So the horizontal component of the velocity is V at the start, it is V at the end, but at all the intermediate stages, whatever be the velocity and whatever be the horizontal components, these horizontal components of velocities will always be greater than V. Think about it, the angle of the velocity is reducing. So the horizontal component will go on increasing. Second, the velocity itself is increasing. Why? Because it is coming down. It is coming down, so the potential energy is getting reduced. So it will be greater than V here. So it will be greater than V. The horizontal component, Vx, would be greater than V. Oh, sorry, I have written it the opposite. Ouch. Wait. So here it was V dash and the horizontal component was V. Anywhere in the middle, the horizontal component Vx has to be greater than V. Here it will be the maximum. Here again, if you talk about somewhere here, it would be smaller than V double dash, but still Vx would be greater than V. Eventually, when it comes to the end, then yes, the horizontal component will go back to being V. Alright, but during the entire period, what you realize is that for entire journey, Vx is greater than equal to V. I hope you realize that. For the entire journey, your Vx is always either greater than V or equal to V. And what is your x displacement? And x displacement is d only. Right, I hope you guys followed this. So you realize in both the conditions, the x displacements are the same. But in the first condition, Vx is always equal to V. So this is the second. For entire journey, Vx is equal to V and x displacement is the same. So now you realize which one is reaching first. Alright, I haven't planned a mentee for work hour energy yet. I thought for 2020 aspirants you should be practicing more. Mentee quizzes tend to be easier because we can't write a lot of questions here. Alright, I can still plan that maybe. So I hope everybody followed this. Alright, let me tell you. So imagine, let's go over the situation, alright? Let's say, let's just get rid of this. And let's start in a fresh diagram. Alright, so okay, Jay brothers. What if it has many curves like a roller coaster? Then yes, it would be difficult to say. Pawan, you are right. Then it would be difficult to say. If it had many curves, up and down curves, then it would be difficult to say. Alright, so Alicia, here, take a look. So here, the speed is V dash. Alright, the horizontal component is V. So consider when it is here. The speed, let's say, is V double dash. Alright, now you realize that if initially it made an angle alpha and finally here it is making at a back angle beta. So you realize initially what I can say was that V would be equal to V dash cos alpha. Alright, can I say that? Right, if V dash was directed alpha downwards with the horizontal, then since the horizontal component was V, I can say that V was equal to V dash cos alpha. Alright. Similarly, if here the speed becomes V double dash, yeah, what is the Vx here? I can say that Vx would be V double dash cos of beta. Now, two things you can see. What two things you can see? That one, also you will notice that beta is less than alpha. Right, the angle is reducing, right? Here you realize the angle will become zero in fact. The angle will be the greatest here. And as you move down this curve, the angle with the horizontal is going on decreasing. Alright. So beta is definitely less than alpha. I can straight away notice that. So if that is the case, what do I know? I know cos beta will be greater than cos alpha. Right? Cos of a smaller angle is bigger. No. Also V double dash increases. Also V double dash increases. Also V double dash would be greater than V dash. Why? It has come down. Right? So it has come down some height y. So it has already lost some potential energy also. Okay. So there are two reasons. One is definitely angle is decreasing. That is one reason. Another reason is that it is coming down also. So it is losing potential energy. Remember that. if it is losing potential energy, because of that also, the Vx will become bigger. Why? Because V double dash is getting bigger. V double dash is getting bigger also. So since V double dash is bigger than V dash and cos beta is greater than cos alpha, that is why Vx is greater than V. Therefore, I can conclude that Vx has to be greater than V. Alright, at any point. Got it? So that is the answer. Alright. So again, this was a very interesting problem. Not too much maths, just a bit of thinking. And that is what your JEE Advanced problems are, right? They want you to think a lot. I mean, the maths part is fine. I mean, they are already testing it in the maths paper, right? So they don't expect too many complex calculations actually. In fact, I remember when I was preparing for IIT JEE, my physics teacher told me, if the solution of any problem is getting too lengthy, then you have to rethink and think that you are doing something wrong. If there is way too much calculation involved, then you must realize immediately that you are doing something wrong. Because IIT JEE will not ask too much mathematical complexity in a problem. I mean, basic integration and differentiation, that is fine. But if you think the solutions are getting very, very lengthy mathematically, just the maths part of it is getting lengthy, then you're doing something wrong. Why? Because the maths is being tested in the maths paper. In physics paper, they want to test how much you understand your concepts and how you can think about them. All right. So tell me if this answer is clear to everybody so that we can move forward. I actually took, I only prepared for 1 year after taking a drop after class 12. All right. So class 11th and 12th, I tried studying on my own. Hi Amit, how are you? So class 11th and 12th, I tried studying on my own along with school, which did not leave me much time. Then I took 1 year drop wherein I joined some coachings. All right. And then because I did not have school, I used to study 8 hours a day. 2 hours physics, 2 hours chemistry and 4 hours maths. So I was the weakest at maths. So 8 hours a day. All right. Next, let's talk about conservative forces and potential energy functions, the relation between them. So any conservative force F vector has a potential energy function U, which we talked about in the last class. In the last class, I told you that you can define a mathematical function U, which will be a function of the position X, Y, and Z, and that will correspond to a conservative force. Now I'm telling you that these two are related like this. Okay, so this may be a little difficult for most of you guys. I hope everybody is familiar with partial derivatives. Is everybody familiar with partial derivation? Please let me know. So this is the relation between a force and its potential energy function, by the way. How did we get to this? I will explain that. But first of all, just to see if you guys even understand what this is. I hope you guys know about partial derivatives. Good. So del u by del x is the partial derivative of u. Now, usually you will realize u will be a function of x, y, and z, right? Because x, y, and z being the position coordinates. I told you guys yesterday that potential energy functions are functions of position. So in general, your u would be a function of x, y, and z, where x, y, and z are the position coordinates of any point. So a conservative force F will be related to the potential energy function by this expression. Now this is called the gradient. All right. So F is minus times, F vector is minus times, this is what sign we use. All right. This sign is used for, the inverse delta. Delta U is del U over del X I cap plus del U over del Y J cap plus del U over del Z K cap. You'll study this in your college. When you reach your college, you'll study about this operator. This is a special operator, and this entire thing, this is called gradient of U. This is called gradient of u function. So gradient of any scalar function gives a vector quantity. So that is how conservative force is related to its potential energy. Alright, so just understand this expression. Alright, this is how they are related. I will show you how. Alright, but even if you are having a tough time following this, do not worry too much. Alright, this is what the expression is actually, and I wanted to just tell you this expression. So this is known as the negative of gradient of the potential energy function. Now in 1D what will happen? If a force is in 1D, let's say, then you realize u will be a function of x only, right? Why? Because if the force is only in x, so any work will be done only by x displacement. The y displacement and the z displacement will not matter, right? Why? Because the force is only in x. So suppose a force is in x only, fx, and fy equals fz equals 0. You have a force which is one dimensional. It acts only in one direction. In that case, what you'll realize is that there is no force in y, there is no force in z. So what happens is now that the potential energy remains only a function of x. Why? Because if the x is same and you move perpendicular to this, you know the work done would be 0. Right? Suppose you are at some x equals 2, let's say, and if you move from here to here, you move along any y. If the x is not changing, the force is along the x, the work would be 0. Work would be 0, which means potential energy would be the same. The change in potential energy would be 0. So the potential energy will depend only on the x, it will not depend on the y or z. Alright, that is what we can say about 1D forces. For 1D force, the potential would be a function of only that dimension. If the force is in x, then u will be a function of x only. Similarly, if you have the 2D force, which had two components, one x and one y, then the potential energy will be a function of x and y. This z will not matter. If you have a 3D force which has three components, x, y and z components, then your potential energy comes out as a function of x, y and z, all the three. So in case u is only a function of x, you know that then we can only write this du over dx. When do we use partial derivatives? When u is a function of more than one variable. When you have a function which involves more than one variables, then we define partial derivatives. Partial derivatives mean that at one point I'm going to take only one as variable and rest two as constant, right? I hope you guys know that. So in case u is only a function of one variable, then I write derivative as du over dx. Alright. So for a 1D force, I can write f as directly as minus times du over dx, which is negative of the slope of the ux graph. Alright. So we're going to talk about proof. So let's say you have a force f vector which is given as fx I cap plus fy j cap plus fz k cap. Alright. So I am imagining a general 3D force. Alright. And let's imagine now that this is my conservative force, by the way. Alright. Now let's imagine it undergoes a small displacement ds vector which is given by dx I cap plus dy j cap plus dz k cap. Alright. So now let's see what will be the work. dw by conservative would be dot of these. So it will be fx dx plus fy dy plus fz dz. Alright, which is nothing but f conservative dot ds. Alright, I hope you guys realize this. And we also know that dwc would be equal to minus times du. We derived this expression yesterday. That work done by a conservative force equals minus times change in potential energy. So I can now write minus du equals fx dx plus fy dy plus fz dz. Now remember, when you're taking partial derivatives, what do? you keep, suppose you're doing partial differentiation with respect to x, then what do? You take your y and z to be constant, alright, and you imagine only x is varying, alright. So if y and x are constant, y and z are constant, what happens in that case? dy equals dz equals 0. Alright, I am saying I am not allowing any change in y and z coordinates. The only coordinate that can change is the x coordinate. Alright, so in that, the moment I say that only the x coordinate can change, that is what partial differentiation is, right? So in that case, dy will be 0 and dz will be 0 because y and z do not change. So what am I left with? I am left with minus du equals fx dx. So what I get from here, I get fx equals minus du over dx. In fact, I write it as del. Why? So as to signify that I have taken these to be 0. Because these are 0, that is why I represent this as del. That means I am taking a partial derivative. Alright. Now by similar logic, you can say if x and z are constant, similarly you will say, if x and z were constant, then minus du would be equal to fy dy. So from here you will realize that your fy becomes minus du over dy, and because I can also write this as del u over minus del u over del y. Alright, I hope you guys followed this. So I'm getting fx as minus del u over del x, my fy as minus del u over del y, and fz as del u over minus of del u over del z. That is what this is eventually. This is your fx. This is the x component of the force, right? Similarly, this is what is this? This is y component of the force, and this is z component of the force. So that is what I'm doing. I hope you guys followed this. I hope you guys followed how I proved this. You need to remember that JEE Advanced has asked problems about this. Alright. JEE Mains mostly they'll only ask you problems over 1D. Okay, so 1D problems obviously you don't need to find partial derivatives. You already know that force is minus du over dx. That's about it. So now let's talk about equilibrium. Now, what do you say? When do you say a body is in equilibrium? So a body is said to be in translatory equilibrium if the net force acting on the body is 0. Obviously, I hope everybody remembers the condition for equilibrium. I discussed this in Newton's laws as well. That equilibrium means that the net force has to be 0. And if only one conservative force is acting on it, and I know F is minus du over dr, and for equilibrium F is 0. So for equilibrium points, I know my du over dr would be 0. Here I am assuming my u is a function of r being the distance from a given point. Alright, so u is expressed only with the help of one variable. That is why I am not using partial differentiation, I am using normal differentiation. Alright. So what I realize is that at point u by dr, the slope of the ur graph has to be 0. Alright. So from those graphs, you will realize that the equilibriums can be divided into 3 categories: stable, unstable, and neutral. Alright. So remember this, guys. Okay. Okay, there was some lag, but I guess it's fine now. Now let's talk about those. So first let's talk about stable equilibrium. Alright, so let's see. This is your graph between potential energy and position. Alright. No problem, Pawan, no problem. I'm glad I could help. Alright, so if you take a look at this graph, this is u versus r graph. So on the y-axis you have u, and on the x-axis you have r. So you realize there are 3 points on which you will find the slope being 0. So one, the slope is 0 here. So du over dr is 0 over here. Then it is 0 over here. And then of course in such a point also you will realize your du over dr is 0. Alright. So you have found in our graph 3 points where the slope of the graph is 0, right? Wherever the slope is 0, you know the tangent is parallel to the x-axis. Now, so these 3 positions represent 3 kinds of equilibriums. Why? Because we know wherever the slope is 0, the force would be 0, right? Because slope is minus times the force, alright? So, these 3 positions will represent equilibriums. Why? Because we know the definition of equilibrium is, it is a point where the force is 0. Now, let's see what I'm saying when I'm calling these stable, unstable and neutral. So I'll say about stable equilibrium that the potential energy of this equilibrium is minimum as compared to its neighboring points. Therefore, mathematically I can say 1 du over dr obviously is 0 for such an equilibrium point. d2u over dr2 has to be positive. Why? Because it represents the minima point of a curve, ux curve, alright. Let's see why we say that. You know that in such an equilibrium, when displacement from the equilibrium position is done, you know, a net restoring force acts on a body and it tries to bring the body back to its equilibrium position. So if you carefully analyze here, suppose an object is at this x. Alright, so this is the position of an object. This is the r at which the object is placed. What happens when I try to shift it here? Suppose I moved it from here to here. See, when it reaches here, what is the slope of the graph? You will realize here the slope is negative, right? Slope here I can see clearly is negative. Why? The tangent is like this. So since, therefore, what can I say about the force? F would be positive because force is minus times slope. So if at any point on this graph the slope is negative, the force acting would be positive. Positive force meaning it will act in the forward direction. So it will push the particle back towards r. Now similarly, imagine what happens when I displace it to here and get it to a point here. Now what happens? What is the slope here? Here the slope is negative. Oh, sorry, positive. Slope I can see is positive, which means what will be the force? F would be negative. Why? Force is negative of slope. So remember this, force is negative of slope. So when you have pushed an object to this position, what is happening? Here it experiences a negative force. Negative force means it's a force in the negative direction. So this force is acting in the negative direction. So this force, again you realize, is trying to push it back to the equilibrium position. So that is what a stable equilibrium is. When you disturb a body from its position of stable equilibrium, then what happens is a force comes into play which tries to push it back to its equilibrium position. Now, the simplest example of this is obviously gravity. Imagine instead of this graph, you had a hole like this. Imagine you had surfaces like this. So you had surface like this, then you had surface like this, and then you had a surface like this. I mean, this is the easiest way to understand the 3 equilibriums. When you keep it at the bottommost point of your hole, the object will be in equilibrium. It will be at rest. It won't move. What happens if I try to leave it here? It will roll down back. If I leave it here, it will roll down back. So this is stable equilibrium, minima position, stable equilibrium. How about unstable? Unstable, I am leaving it just at the top. It might be stable. The moment I shift it here, it will roll down. It will move away from the equilibrium position. Similarly, if I keep it here, it will roll down again. So this is stable equilibrium. Stable means when you disturb the body from its equilibrium, it tries to come back to the equilibrium. This will be unstable equilibrium. Why? The moment you disturb the body from the position of its equilibrium, it goes farther away from the equilibrium. However, suppose the mass was kept somewhere here. Now if I kept it here or I kept it here, what will happen? The moment I left it, it won't go anywhere. It is happy being where it is. So this is called neutral equilibrium. Alright, I hope you guys understand the difference between stable, unstable and neutral equilibriums. Alright, you can see it from here also that the forces are such that they will always act or bring the body towards the equilibrium position. Alright, so that is what your stable equilibrium is. So stable equilibrium points are minima points on your ux or ur or uy, whatever your equation of whatever the graph between u and whatever dimension is. Alright, so all the minima points represent stable equilibrium. Next, unstable equilibrium. The potential energy at this equilibrium is the maximum compared to its neighboring points. You know, points always want to attain the minimum potential energy situations, right? So whenever it might be in equilibrium here, because the slope is 0, so fine, the force acting on it is 0, so it is in equilibrium here. But the moment I push it here, it will go down, it will move forward. The moment I push it here, it will go backward. Why? You can see slope here is negative. Slope equals negative, which means force is positive. Positive force means it is in this direction. And inversely, in this direction, you will find the force becoming negative. So you realize all the maxima points on your UR graph will represent unstable equilibrium. So mathematically, what you can say? Mathematically, you can say that for these points, du over dr is 0 and du2 over dr2 is negative. When displaced from these kind of equilibriums, a net force acts on a body which tries to move the body farther away from the equilibrium position. Alright. Now these are obviously the maxima points of UR graph. Next and finally, neutral equilibrium. So neutral equilibrium is this part, as I told you. When you displace a body from here, it does not go anywhere. Force here also 0. Why? Because the slope is still 0. And force here also 0. Why? Because the slope is still 0. So when you take it here, it remains here. When you take it here, it remains here. It's not going anywhere. So you realize there the curve has gotten flat. Ux curve has gotten flat. So mathematically how you can say that the potential energy in this kind of equilibrium becomes constant and it is same at all the neighboring points also, which means your du over dr is 0. That is fine. That is true for all equilibriums. But for neutral equilibrium, your d2u over dr2 will also be 0 because the slope is not changing. It is remaining 0 at all the points. So the slope of slope will also become 0. Now when displaced from equilibrium, such an equilibrium position, no net force acts on the body and hence the body remains in its new position. These will be the flat points of the UR graph or UX graph or whatever kind of graph is given to you. So remember, all maxima points represent unstable equilibrium, minima points represent stable equilibrium, and flat points, flat parts will represent neutral equilibrium. So why don't we practice a problem? Let's quickly practice this problem. So you've been told that the potential energy of a conservative force field is given by ax square minus x, where a is a positive constant. Find the equilibrium positions and their nature. You have to find the equilibrium positions under the action of this. Okay. Well, you can get in touch with me here only or maybe on the Unacademy platform. You can leave me a message there. I'll try and answer you. See, I don't think it's a very good idea for me to be giving my number on a public platform, you know. Anyway, so let's talk about this problem. Here you've been told. Again, I don't want to say it on a public platform. That'll be asking for trouble. Okay, so let's talk about this question. The potential energy of a conservative force is given to you as U equals ax square minus x. Alright. No, I still don't think I can give out any personal information over here. This is a public platform, and you know, giving out any personal problems over here, personal information here would be asking for trouble. Alright. I'm so sorry, but again, even if the intention is just to give you any contact detail, it is available it just goes out there. You realize that. So yeah, let's just avoid that. All right. So why don't we solve this problem quickly? I know for all my equilibrium positions, my du by dx will be 0. So let's try and find out du over dx. Du over dx would be 2ax minus 1. So putting that equals 0, I get the equilibrium position that I'm getting is equilibrium happens at x equals 1 over 2a. So that is one point of equilibrium. Alright, x equals 1 over 2a is one position of, no problem, is one position of equilibrium. Now, is it a stable equilibrium? Is it an unstable equilibrium? Let's try and find d2u over dx2. So when I try to find out the second derivative, what I'm getting my second derivative as 2a. Alright, and what have I been told? A is a positive constant. So I realize that this is positive. If this is positive, then I know what kind of equilibrium this is. This represents a maximum, minima point. Alright. So this is stable equilibrium. Alright. d2u by dx2 represents a positive. It's positive, so I know this is a minima point. Minima point means the position is of stable equilibrium. Alright. Now let's quickly just talk about power. Would you define power as? Power is defined as the rate of doing work. Alright, in practical life you realize that the rate of doing work also matters. Alright, consider a situation. You've gone to the market to buy two cars. I tell you that car number 1 and car number 2 are there. They have the same mass, they have the same top speeds, let's say 150 km per hour or let's say 200 km per hour. Both have the top speed same. Both have the same mass. Now I'm telling you, this guy can go from 0 to 100 in 10 seconds. And this guy can go from 0 to 100 in 6 seconds. Now you realize, in going from 0 to 100, both the engines would have done the same amount of work. Why? Because the change in kinetic energy would be the same. As I said, the masses are same, the change in velocities are same, so the initial kinetic energies are same, the final kinetic energies are same. So you realize in both these situations, the work that is being done by the engine is same. However, which one would you prefer? Probably this one. Alright, the one which gets to from 0 to 100 faster. So you realize many a times in practical life, not only the amount of work being done is important to us, but the rate is also important. Sometimes I need work done faster. Alright, I may even want it done slower. So it may be both the ways. But it is important for me to know the rate at which the work is being done. It may just matter to me. Alright, so that is why we define a new quantity called power. Power is defined as rate of doing work. Yes, of course, it obviously costs more. Alright, so power is defined in two ways, one instantaneous and second average. So let's go over that. Let's see what all do we know about power. Of course, power is a scalar quantity like all the three terms in this chapter, work, power, and energy. We are dealing only with scalars. And the SI unit for power, technically it would be work upon time, right? So joule per second, but this is commonly called, given a new name, watt. Alright. Now, average power is defined as delta W over delta T, and instantaneous power is defined as dW by dt. Now, you can also express instantaneous power as F dot V, where F is the force and V is the instantaneous velocity. Why? We are just saying, we know P equals dW over dt. dW can be written as F dot ds over dt, and ds over dt can be replaced as V. So F vector dot V vector is also a way of representing power. Alright. Now, because P equals dW over dt, I know what will W be. W would be integral of P dt. And what is integral P dt? It is the area under PT graph. So also remember that the area under PT graph is equal to work. Alright. So that is it. I mean, power is a simpler topic. You can just, there is not too much conceptual depth in that. Alright. So you can just quickly try two problems. Take screenshots of these problems. You can try them later. Alright. Because I'm getting late. I have to start another session in another 15 minutes. So take a screenshot of this problem, try it on your own. Take a screenshot of this problem also and try it on your own quickly. So let me read it out while you're taking screenshots of this problem. So the problem says a ball of mass 1 kg is thrown up with the initial velocity of 40 meter per second in vertically upward direction. You find the power of gravity at t equals 2 seconds and t equals 4 seconds. Okay. Similarly, there's your second problem. A particle starts moving with an acceleration of 2 meter per second square. You have to find the average power of the net force between time instants of t equals 0 and t equals 5, and you have to find the instantaneous power at t equals 2 seconds. Okay, take the screenshot of this one quickly. Alright, quickly take the screenshot of this one. You can take the screenshot of this one also. I'll give you like 2-3 seconds. Or let's give you 5 seconds for your screenshots. Alright, so I hope you got the screenshot of this. So try these problems and this will be easy. Alright, so that is it. I think I'll take a leave now. And before I leave, let me remind you how to get Unacademy subscriptions. Go to your plus segment, select your goal as IIT JEE and click on that get subscription button. Alright. So once you have gotten, installed your app and you're getting your subscription, do not forget to use my code. It is RD Live and this code gives you an additional 10% off. If you like today's video, if you think it helped you, taught you new things, then press the like button and share it with your friends. Also, do not forget to press the bell icon right there for further notifications and schedules about my future lectures and schedules. Also, the PDF file for all the slides used in today's lecture will be available in the download link in the description box by tomorrow. Come back tomorrow to download that. Also, don't forget to join us on the Telegram app. Alright, using the link shown above. I will give it to you very, very fast, Dinkar. Also, use my referral code again to get 10% off with your Unacademy subscription. So, Dinkar, the difference between the Plus and the YouTube is somewhere similar, which is the difference between the JEE Mains and the JEE Advanced, right? See, in JEE Mains and JEE Advanced, the syllabus is the same, but the levels are different. So, that is the same thing. The syllabus is saying I'll be teaching you the similar concepts, but in Plus, the preparation would be more rigorous. There will be practice sheets given to you, your performances will be tracked, and you will be guided individually as to where all you can improve. Alright, here everybody can watch it, so it is slightly random. I do not keep track of things. I do not keep track of everybody. There, when you are in a batch studying from me on a regular basis, then that will happen. You will get more personal guidance. And of course, the practice, I will give you regular practice sheets and the question solving will be more rigorous. Alright, so that's the difference between Plus and YouTube. Alright, so with that, I'll take your leave. I'll see you guys tomorrow, or rather in another 10 minutes.